Hello everybody. So here we are going to see computer system architecture. So in this unit, this is the last unit. We have already covered all the other 9 units. I have taken up some few problems like this and we have solved the problems. So today we'll see computer system architecture. So if you are not aware of the other units, I shall give those links in the description, so you can go and check out those problems. Okay, those units I've covered all the 9 units. This is the 10th unit. This is the last unit. Okay, here we have taken some 5 problems and we'll try to solve them. So the first problem, the decimal floating point number is 85.125. Its 32-bit representation written in hexadecimal form is. So this is the question. So they're given a decimal point number. Okay, decimal number that they're given as 85.125. We have to find out the 32-bit representation and we write it in hexadecimal form. Okay, to solve this problem, see the value is this point, decimal point value is 85.125. So this is the decimal point value. So you have to write the 32-bit representation. So to write the 32-bit representation, we need to know some formulas like whether it is 32-bit representation means what type of representation. Okay, so here we have two forms, that is implicit form, implicit notation and explicit notation. So if the notation is not given, right, here it is not given, you have to write an implicit notation or explicit notation, then you have to use the implicit notation only. If it is given that you have to write an explicit notation, then explicit notation you can write. So implicit notation means write of the form 1.m. M is the mantissa. Mantissa means the portion of bits after the decimal point, that is mantissa 1.m into 2 power e. Okay, here for explicit notation will be 0.m into 2 power e. So e is the exponent. So e, what is the value? Here we have two types, that is, this is a 32-bit representation. They have asked here that is a 32-bit representation. So for 32-bit representation, so how will what is the format for 32-bit representation? See, first bit will be the sign bit. Okay, first is the sign bit. Next will be the exponent. Next will be the mantissa part. Okay, this is the 32-bit representation. Okay, so in 32-bit representation, we have to know how much bits are there for the sign, exponent and mantissa part. For 32-bit representation, the value will be, for sign bit always it is 1, so 1 bit. If it is a negative number, the sign value will be 1. If it's a positive number means the value will be 0. So sign is assigned 1 bit. So exponent will be 7. So exponent will be 8. Exponent will be 8 and mantissa will be 23. This is for 32-bit representation. Similarly, for 62-bit representation, if it is given as 64-bit representation, then it will be like sign bit, exponent, mantissa. Here the values will be 1, 11 and 52. So the values of bits will be 1, 11 and 52. Okay. So you need to know this representation. We need to know the number of bits. So you have to know the number of bits. You need to know the implicit notation and explicit notation. Next, we find what is the value of e. So what will be the value of e? E will be small e, that is exponent as 2 power e value 2 plus 127 in case of 32-bit. That is the bias exponent we are adding. So e is equal to e plus 1023 for 64-bit representation. Hence, no, we need to find out. So exponent is this value. Okay, this exponent value is there. No, this value we have to write is e plus 127 or e plus 120 1023 for 64-bit representation. Here, in the given problem we have 85.125. First it is a decimal number. First you have to convert this decimal number into a binary number. Okay, first convert that into ones and zeros. That's binary, write it as bits form. Okay, first 85.125. So how will you write the decimal binary equivalent? So we will divide by 2. So 85.125. So we divide by 2. 2 2s are 4. Made a 1, so 2, 21, and made a 0, 2, 10, made a 1, 2, 5, made a 0, 2, 2, 4, made a 1, 2, 1, made a 0. So you have to move from the bottom to the top, as I told you. So moving to bottom to the top, what will the value be there? So it will be 1 0 1 0 1 0 1. Okay, fine. Next we'll see the decimal part. So decimal part 0.125. 0.125, how to convert to binary? We've already seen, no? Like how to convert the decimal value to binary value. You have to, suppose it is in after the decimal point, like it is given in points, means you have to multiply by 2. Okay, here we divide by 2. If it is in points, decimal points, means you have to multiply by 2. Now we multiply it by 2, we will add the value. See, 2 5s are 10, 2 2s are 4, 1 5, 2 1s are 2. So 0, write 0 here. And then next what value will take? We will take this value, only the decimal part. So 0.25 into 2, which is 0.50. Now 0.50 into 2, which is equal to 1.00. Now when you have to take only decimal points, so what will take? Will take only 0.00 into 2, which will be again 0.00 only, no values. So even though any times you repeat, the value will be 0 only. So here how will you take the values? You will take from top to bottom. Okay, here to take from bottom to the top. Here we'll take from top to the bottom. Okay. Now we'll write the values. Now what values will write? We'll write these values. These 0 0 1 0. This is the value for 0.125. Now we'll write the value here. So the value is 1 0 1 0 1 0 1 point, now 0 0 1 0. So this is value. You can add any number of zeros. Now what is mantissa? Mantissa is anything above after the decimal point. So after decimal point, what all values I have, that is the mantissa. So here we have exponent and mantissa. We have tried it in this form. Okay. Now we have to find out. We write in implicit notation, right? We have to write in implicit notation only because it's not mentioned anything. So we'll by default we have to write it in implicit notation. This is the default notation. Okay, so we have to write the form 1.m. So already we have this number. We have written in decimal form. We have written it is in the form of like this, the decimal point. Now I have to convert this into a form. How will I have to convert? I have to convert to 1.m. I have to convert like 1 point something. So what will I do? I will shift this. What I'll do? I'll shift this decimal point places till reaches this one. Okay. So I'll shift what? How much places I'll shift? So 1, 2, 3, 4, 5, 6. So here if I shift the point to 6 positions, I will get as 1 point. I'll get what? I'll get 1.010101. Then write as it is. These numbers will write as it is after the decimal point only, but you can write as it is. Now you have shifted the decimal point here. So you can write 0010. Okay. Now what will write for 2 power, what will come? See, you have shifted 6 positions, then it will come 2 to the power of plus 6 or minus 6. It will be plus 6 because why? See, we have taken a bigger value. 85 is a bigger value. Maybe it is a bigger value converted into a small value, like we have converted this into 1 point something. So that means we have to add it to be positive only. Okay, so remember it will be positive value when you shift it right and make it small. You have to shift, you have to write in the bigger value plus. So it will be plus 6. So plus 6 and 2 to the power 6. So what is the value of E here? Now E value is 6. So substitute this value. No? Here we have found out the exponent value. Exponent value will be e plus 127 for 32-bit. So what is the value of e here? Now for 32-bit, e is equal to e plus 127. E plus 127. Now this e is the power which comes here. That is 2 power whatever power you have, or how many times you have shifted. So that power is that e, small e. So exponent value. So 6 plus 127. 6 plus 127 is what? It is 133. So the exponent value is, now we have found out, that is, so exponent value is 133. Now again we'll find out the decimal value for 133. Okay, now find out the binary equivalent of 133. So binary equivalent is 2, 6, 12, 13, 66, 1, 33 and 0, 2, 16 and 1, 2, 8 and 0, 2, 4 and 0, 2, 2 and 0, then 2, 1 and 0. So we have to take from the top. So the value will be for 133 be 1, 2, 3, 4. 1, 2, 3, 4, 1, 0, 1. So this is the equivalent of 133. That's it. We have found out all the values, right? Now we have to write the values. Here we have found out the binary for 185.125. That is this value. We have found out the value for the exponent, that is 133. And we found out the binary also, the sign bit. So what will be the value of the sign bit? Here it is a positive number. See, this is a positive number only. So decimal value is 85.15 is positive value only. So now what will be the value of the sign bit? The sign bit will be 0 only. If it is a negative value, means we have to put this as 1. If it is a positive value, so this sign bit will be 1 only. So we'll write first sign bit, then the exponent part. Exponent part is what? This one. This is written as in form of what? In 32-bit representation. What will come? See, sign is 1 bit, then exponent is 8 bits. So we write as 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. So already it's in 8 bits. Okay. Then we have to write the mantissa. Now mantissa, how will you write? See, mantissa, how will you write? You have taken, right? You have taken that 1 point something written, no? Here 1 point something. So 1 point we have taken. This is the implicit notation. So this is the mantissa. So this is the mantissa. This is the mantissa part. Okay. Now write this value here in the mantissa part. So here we find in 32-bit mantissa how many bits are there? There are 23 bits. So we have to write 23 bits here. Okay. For first I'll write sign bit. So sign 1 bit. So what is the value? The value is 0. Now exponent 8 bits. So write the value. See, here we have found out the value of 133, right? So 1 0 0 0 0 1 0 1. So it is the exponent part, that is 8. Okay, it is 133. We have finished. Now write the mantissa part. We are writing in what? 23 bits you have to write. So where is the 23 bits? See, we have only these bits. See, 85 value will be 0 1 0 1 0 1 0 1 0 0 1 0 0 1 0 1 0 1 and 0 0 1 0. So written the values here. Sign bit 0, exponent bit I have written the value 8 bits, and then mantissa I have written the values as I have got, that is 0 1 0 1 0 1 0 0 1 0. So find how many values are there. See, there is 1 2 3 4 5 6 7 8 9 and 10. Now we have to add zeros up to 23. So 10 11 12 13 14 15 16 17 18 19 20 21 22 23. So these are the values of the zeros you have to add, so that we have to bring it to 23 bits. Next we have to just write the hexadecimal. This is the final set of bits. Okay, this is the final set of bits. Now we have to write it in the hexadecimal form. So to write this in hexadecimal form, what will you do? Actually, you have a binary digits. Now you have to write it in hexadecimal format. So what will you do? You will take in fours, right? It's hexadecimal, right? So you take fours. So 0 0 0 0 take fours, 0 0 0 0 take 4, next 4, then 0 0 0 0 0 0 0 0 take 4. Next you take this value, see here, take 4, that is 0 0 1 0, that is 0 1 0 0. Okay, this taken 4, this value 0 1 1 0 1 0. Next from this one, um, 0 1 0 1 is one value. Next 0 1 0 0, this one value, and then last 0 0 1 0 is one value. Okay, now we have categorized as four bits, right? Because you have to write in hexadecimal, so we write each and every four zeros and ones as fours. So taken as fours. Now move from the left. Okay, see here we have 0, 4 zeros are there, so the value is 0, then again 4 zeros are there, value is 0, then again 4 zeros are there, value is 0. Next come to this one, start from the right. See, find out what is this value. 0 1 0 0. What is the value? 0 1 0 0. The value is 0 1 0 0 is 100, that is 4. Next 1010. So what is the value? 1010 means it is 10. Okay, decimal 10. So decimal 10 means hexadecimal is A. Next see 1010, again 1010. Okay, so again the value is the A. Well, then finish this one. Next this one 0010. So what is this? 0010. So it is 10 only. 10 means what? It is 2. So write 2. Next is 0010. So 0100, that is what? What is this value? 100. 100 means it is 4. Okay. So the value is finally, the answer is 42AA 4000. This is in the hexadecimal. Okay. I hope this is clear to you. We'll see the next problem in the next video. Okay. You need to know the formula for doing this problem. Writing in either 2-bit representation or 16-bit representation, you have to know the formula. We need to know how to read the representation, what is the implicit notation, and then how to find out the exponent value. So we need to find out all these values in order to complete this problem. Okay, this is the answer. That's 42884000. Thank you.